Hello everybody. In this video I'm going to be going over what the step up from GCSE to A-level maths is like, how you can prepare for it, and I hope to get you a bit excited, a bit interested in what sort of problems and topics it covers. For you eager students, I include a link in the description below to a very reasonably priced 40-page ebook which goes into depth into the contents of this video. It contains loads of preparation problems and exercises. It's got some reading lists, watching lists, and also links to loads of super useful resources that you probably will end up using during your A-level. At the end, I'll also be going through a couple of examples of A-level questions that you can actually solve now, and you can find many, many more in the book. So let's get to it. Let's talk first about what makes the A-level more difficult and why it's hard to adjust to. So the first one, I think probably the most important, is time. So A-level is bigger, more difficult, and goes by much faster than the GCSE. You'll be expected to cover more material, which is much more abstract, in much less time. So this can be a real shock for students. So you've been enjoying their well-deserved summer and then they find themselves overwhelmed within 2, 3, 4 weeks of coming back after the break. So you have to remember at GCSE you were tested on topics like fractions, decimals, perimeter that you might have been dealing with for almost a decade in maths in school. In A-level it's completely different. You're going to be introduced to brand new mathematics, and in less than 2 years you're going to have some big important exams on these. You really don't have the luxury of time, so I recommend that you do your best to start ahead, stay ahead, because catching up once behind, although possible, I mean I did it, but catching up once behind is not easy. The second thing that I want to talk about with A-level maths is it requires absolutely rock solid foundations. There's just so much material to cover that your teacher will not have the time nor the will to walk you through every part of, and they're not going to look at everything in tiny detail. They're not going to hold your hand and point out every last bit. You'll just be expected to get some things without the teacher highlighting them. So to prepare for this new kind of learning, your number sense, your algebra and your graphing skills in particular need to be fast and accurate. Without these, you'll be struggling just to follow the train of thought, let alone take in the underlying mathematical argument. So what do I mean by these things? So number sense is just your ability to quickly and easily, almost instinctively reason with and compare and understand things about numbers. So a simple example is knowing that the product of four odd numbers and one even numbers is even. Yeah, that's the first thing. Algebra is all about cleanly and effortlessly communicating and recording mathematical relationships and ideas. It's the language of mathematics. If your language is limited or full of mistakes, so will your understanding of the deeper material be. Graphing and visualization skills are essential for grasping the essence of many ideas at A-level, but especially calculus. So that's integration, differentiation. Until you can quickly mentally switch between viewing functions as a number machine, like numbers go in, numbers come out, but also as curves that have roots, intercept, potentially symmetries, really steep bits, really shallow bits, peaks, troughs, you really won't have an easy time at A-level maths. So in my ebook, I've got a whole section of exercises on each of these three main topics: number sense, algebra, and graphing. And you can use these to sharpen and preserve your skills before the A-level starts. If you're enjoying this video so far, please consider subscribing, smashing the like button, and don't forget to leave a comment at the end. And please feel free to suggest any future content that you would like to see. Another thing that's quite important, that's a big step up from A-level, is study skills. So if you're somewhat mathematically talented, you maybe found GCSE relatively easy, and it didn't require much structured studying. You just did the past papers, you worked on the questions that you got wrong until you got them right, and then you took the exam. At A-level, you probably need to up your game. You're going to have to learn a lot more in a lot less time, and collecting your notes, reviewing them, and making sure that they're in your long-term memory is going to be something that you're going to probably have to put more work into. If you prepare for the A level over the summer, you can begin some good study habits before you get overwhelmed. In the ebook, I also give a few examples of useful techniques to help you study for A level. Now, in the last bit of the video, I'm going to give you a flavour for the A level by looking at a few problems that you can appreciate using mainly just GCSE math skills. I hope you find them exciting, motivating, and interesting. And my ebook contains a whole section with problems like this. Hello everybody. The first question of an A-level style that we're going to look into is this one. A rectangle has perimeter of 40 meters. What is the area, the biggest area that it could possibly have? So let's just draw this out with a diagram. And let's try and write this in. So what I'm going to do is I'm going to call the width x. And then what we know is that we're going to call the length y. Now what we know is that we know that 2x plus 2y equals 40. So that means that x plus y, of course, equals 20. So y is equal to 20 minus x. So I'm going to put that back into here. And we're going to have this rectangle with dimensions x and 20 minus x. And then we know it has an area. So what's the formula for the area? The area is just going to be x times 20 minus x. Now, if we expand this out, we get a quadratic. We get minus x squared plus 20x. Now, if we complete the square on this, we'll get this. So first we take out the negative. And that become that minus 20x. Now let's complete the square on it. So this becomes x minus 10 squared minus 100. If you expand that out yourself, you'll see. Now, what does this become? Let's put the negative back in. Plus 100. Now let's have a look at this term here, the squared term. Well, what's the absolute smallest it can be? 0. Therefore, the biggest that this can be is when this is 0. So you get 0 plus 100 equals 100. Let's go back to the start. So what this means is that when the rectangle is 10 by 10 by 10, so i.e. when it's a square, you will get the biggest possible area. Now these are called maximization problems, where you have to try and find the maximum sum value you can possibly take. This is really, really different from the kind of things you're asked to find at A level. At GCSE. Generally you're given a particular problem to solve and then you just find the number. Whereas here, we're told, well, the area could take any value, any of them are legitimate, but which one fulfills a certain criteria? Now, I've still done this using completing the square, but there's another way to do this using something called differentiation, which is a much more powerful tool and works with with all functions in theory. It's a whole way of finding when things are maximum or minimum. All right, so that's the first kind of problem, is this calculus problem. Now the second problem involves adding together an infinite number of things. Now I'm going to do this in a bit of a roundabout way, but you can still see how you could solve it. So let's imagine we had a fifth plus a 25th plus a 125th plus a 625th, and going on forever. What if we were trying to add together an infinite number of fractions? Could this still add up to a finite number? Well, let's try and spot a pattern. So if we just add up the first term, we get 1/5. If we try to add up the first two terms, you're going to get 5/25 plus 1/25, which is going to be 6/25. Now, if we then try to do 6/25 plus 1/125, this, you can work out yourself, is going to be 31/125. And then if we add on the final one, 31/125 plus 1/625, you're going to find this becomes, what is that, 155, 156 over 625. Now there's a few ways to approach this, but one, probably the easiest way, is to just look at what these things are as decimals. Okay. This is 0.6. 0.2. This is 0.24. This one, I think, escapes my mental maths. Let's do this. 31 over 125 is 0.248. And now this one, 156 over 625 is 0.2496. Now clearly these are all increasing each time, getting bigger each time, but the amount they're getting bigger by is getting smaller, and they don't seem to be able to get past a certain number, and that number is 0.25. Now, what this means is if you add all of these together in a roundabout way I've shown, then you're going to get to a quarter, 0.25. Now in A-level maths, you learn a whole bunch of techniques to really formally add together an infinite number of things. Now infinity is one of these things that, when you're first a kid and you learn about numbers and you learn they go on forever, you realize that you can keep counting, you'll never ever reach the end. But it's actually quite a difficult thing to handle. And I think problems like this give you the first kind of taste of what some of the interesting things that you can do with infinity. Thanks for watching. I hope you found this video really helpful and useful. Don't forget to like, comment and subscribe so I can keep creating more great content. Thank you.